Okay, hello and welcome to Going Native episode number 54. Today we got two topics to go through. First, we're going to talk about the new RC that's available for Visual Studio 2017. We're just going to do a really quick overview of the top new exciting things inside that release, and then we're going to spend the bulk of our time on the new Vcpkg package manager for C++ developers on Windows. But first, I'd like to introduce Augustin Popa.
Hi.
Tell them what you do.
So I'm a program manager on the Visual C++ team, and I basically help work on developer productivity features.
Okay, great. And also, he's one of the behind-the-scenes talents on the Going Native show. For those who are really interested in the inside baseball, how we make the magic happen.
I'm one of the producers / occasional editor of Going Native.
That's right. The producer is a very important role. All right, so let's talk about Visual Studio 2017 RC. So I think we have three top-line things we want to talk about here. We want to talk about the new acquisition experience. We want to talk about some of the investments we made into performance, and then you're going to go through sort of the cool new productivity, be a super productive developer, be a hero kind of stuff, all right? All right, so I'm going to start with the fundamental stuff. Let's talk about the new acquisition experience. Visual Studio, we kind of put it on a bit of a diet. So there's an entirely new installer. I want to say that we 100,000% heard the feedback from Visual Studio 2015, where we made it so that C++ was sort of optional install. And people are like, well, that's great, but can we make C# an optional install? And I'm excited to tell you in Visual Studio 2017, you can indeed pick just the languages and workloads that you care about. So there's not, I don't want to go into too much depth here, but I want to say that, we wanted to make sure that we were being respectful of the amount of time you have to wait to get these installs going and respectful of the size of your disks. So we are much smaller. You can go and you can install just C++. Within C++, we give you all sorts of bells and whistles to make sure that you can install only the things you care about. If you don't care about C++ CLI, don't install C++ CLI. Also, much fewer things on disk. It's a much prettier installer, I will say. That's very easy to go in. We have 4 basic C++ workloads. We have the desktop experience. This is sort of the default. I have an MFC app and I want to build for the Windows desktop. We have a separate one for the Linux workload. So if you're doing Linux, for instance, you might not even need our compilers installed, so we won't do those down. It's a very lightweight install at that point. We've got the multi-device development workload, which will allow you to do things like Android and iOS development. And finally, we've got a games installer that will help you kind of grab things like the Cocos 2D installer and get just the things you need installed to go write a great game in C++. So that's great. It's much smaller. I think there are a lot of scenarios where we're installing, especially for like the Linux one, where we're not laying down the compilers and the libraries, which are quite large. These sub-gigabyte installers. So I'm really excited about that. I'm 100% sure you'll spend less time installing. The second major area I want to talk about is performance. We wanted to make sure that this time, even though we always are working on performance, that we worked on performance in a way that every developer who went and used the product will experience a difference. And our major areas of investment this time were in both loading solution times as well as build throughput performance. So I'll start with load solution performance. We've completely re-architected how that works so that there's like an actual database behind the scenes. So we're pulling way less information into memory, so you should see memory usage drop down, as well as much faster operations. We are very frequently seeing customers reporting to us that when they use the pre-release bits with the new feature turned on, that they'll get almost like 50% of their old load times. Likewise, we've taken the fast link work that we did in Visual Studio 2015 and made that even better, and we've turned it on by default. So a lot of people, we actually know that not that many people were using fast link, and now you'll kind of get the opportunity to kind of get opted into that. You can turn it off. But you should see much better link times in Visual Studio 2015. And also in just the core of the product, there's been all sorts of improvements for things like startup time has been improved. There's been some great debugger memory usage reductions. So I'm hoping across the board you're going to see a much more performant Visual Studio 2017. All right, let's start to talk about productivity. What kind of stuff did we do that every C++ developer using Visual Studio can take advantage of.
All right, so there's quite a few things to talk about, I guess, when it comes to productivity. So I guess the first two major things to talk about, we have a new open folder experience, as well as a new CMake experience.
So like open folder, like what does that buy us?
So, I mean, I guess the issue here was that there's a lot of C++ projects that were not necessarily created using the Visual Studio project system, and importing that in, if you're using Visual Studio, could be a bit of a challenge. And what we're trying to do is create this concept where you can basically just go into the IDE and you have this open folder feature, which lets you basically just pull in your code and easily get started with it.
Right,
so
without sort of getting locked into some sort of Visual Studio project system. It's really us going out and saying, like, bring your code to us. It's relevant for every developer, even one who isn't using MS Build, for instance.
Yeah, exactly. And that's basically the sort of thing that we're going for here. And it was a pretty big area of focus for us, actually. We definitely had a lot of devs working on it for quite a while. And the other thing is we have a kind of like a preliminary early CMake experience. So we're adding a little bit of support there, and it's an ongoing thing, but it's definitely something we want people to take a look at and try out. And we're going to have blog posts as well as some additional videos that go over these two experiences in more detail. Definitely highly recommend checking those out.
Right, I've been very impressed with how quickly CMake has been sort of picked up as a sort of, I don't want to say pseudo project system, but I don't know, whatever you want to call it. But a lot of code out there uses it, and we want that code to just immediately light up in Visual Studio, especially for people coming from other platforms or targeting cross-platform.
Yeah, and we recognize the growing popularity of CMake, and we want to make sure that we have a solution for developers for that in Visual Studio.
Right.
All right, so the next thing, I guess, is IntelliSense. So we've made two major feature changes to IntelliSense. The first is we have a new experimental predictive IntelliSense feature, which you can turn on in Tools Options. And basically what that does is it's a way to narrow down the list of results that you see. We're basically it's basically context aware. We're trying to guess what kinds of results are most relevant to you based on your particular scenario. And it's something that we will continue developing over time. But it's definitely, it's based on the feedback that we got that a lot of the time, especially on these larger code bases, even though IntelliSense does text matching, so as you're typing characters, it's narrowing down the list for you, you might have a lot of different things that maybe start off with the same set of characters, and you still have to do quite a bit of work to actually auto-complete your code. So through this, we're hoping that that's going to be helped out quite a bit. The other thing is we're adding a number of IntelliSense filters, which allow you to further narrow down the list of results to different kinds. So if you just want to see functions, for example, you can make it so it just shows functions. Right. And we have a number of different types of filters there. So hopefully that should help as you're editing your code, basically be able to write code faster.
Yeah, in some ways it's a performance feature too, because it's like you get to the autocomplete result you want faster. Yeah. In some ways, yeah.
Yeah, definitely. So the next feature is Find All References, which has seen quite a few changes. Basically, what we did was we recognized that it can be difficult managing a large list of results. So if you're looking for all the usages of a particular member function in a class, for example, when you have a really long list, it can take a while to populate the list, and it's hard to really navigate your way and find the things that you want. So what we did was we added the ability to group the results together in different ways. So you can basically change the view of things in the results list. You can also sort the different columns. We actually added a column that tells you whether an entry is a read or a write, which can be very helpful when you're looking for that kind of information. And we also added a number of filters. You can actually filter for each column category to only display the types of results that you're interested in. So if you're seeing a lot of extra stuff that you don't really care about, you can basically exclude it.
Again, it's this managing complexity for very large code bases idea.
Yeah.
It's also probably worth mentioning that I demoed a bunch of these features in the CPPCon talk that's up on YouTube and on Channel 9 now. So that might be a good place to, if you want to just really dig in and see what these things look like.
Yeah, definitely. And I also did a Connect video, which goes
right.
over
And those are
as
nice
well.
and short.
Yep.
We'll get the links below.
Yeah, we'll have them in the video description, I'm sure.
I'll make sure the producer does it.
And just the last thing I had to say about final references is incremental population. So you start seeing the results more quickly and being able to interact with them. And that should be helpful because you won't have a longer wait time to basically start to actually go to where you want to go.
Perf.
Yeah, perf, exactly. Next we have Navigate To, which is no longer known as Navigate To, and henceforth I won't call it Navigate To. We'll call it Go To because that's what we're calling it now, because that just made more intuitive sense to developers from our research. And essentially what we did was we added a number of different filters. So for those of you who don't know, to activate it, you basically do Control comma, and it gives you a search box, and you can look for different items of interest in your code base. So for example, if you want to look for a particular member function of a class, you can just search for that. But now you can actually filter for different things. So for example, there's a filter for files, if you're looking for files. If there's a filter for types for members as well as for symbols, if you're looking for different types of code elements. And we also kind of folded in go-to line number, which was previously known as go-to in Visual Studio, but we couldn't have two things called go-to, so now it's go-to line number. It's more specific in terms of the way it's called, and it's still accessible by Control-G, so you don't have to worry about the interaction being different to you as a user. But basically, this just means that it should be easier to navigate around the code base and find the different things that you're looking for. And the last thing I wanted to talk about there was we're getting into this realm of style enforcement. And what we did was we added support, and this is across VS, not just for C++, but we added support for editor config files, which basically allow you to set different rules around how your code is formatted. So for example, if you decide that your development team needs to have 8 spaces, indents of 8 spaces rather than 4 spaces.
No, I would literally kill that person. What? Oh, okay. No. Whatever you want to do is fine. It's fine.
I really hate the 8-space indent, but I know some people like it.
Okay.
But yeah, you can basically configure that kind of stuff, and you basically have a file called .editor config, which you dump somewhere in your project, and you can set different rules for different parts of your project. So if you have all your code files organized in different folders hierarchically in your if you go in Windows File Explorer, so you can actually have different editor config files and set those rules differently. And the use here is when you're working on a team and you want to check in your code, you want to make sure that everyone has kind of a consistent style. And that's basically why we're investing in this.
All right, so Visual Studio 2017 RC, by the time this video is out, it will be out. Please, please, please go ahead and download that thing. Try out these new features. If you're not seeing the performance benefits, send us an email. If you love the stuff, also send us an email. I like compliments, I'm human. And if you're finding any bugs, we're trying to be as active at fixing those quickly, making sure that we land a fantastic final complete version of this in 2017. Great. Okay, so we talked a little bit about Visual Studio 2017 RC, and now I want to transition to talking about a new thing that we have working, which is the Vcpkg C++ package manager for Windows. But first, Robert, introduce yourself to the people at home.
Hi, I'm a developer on the Visual Studio
What's your name,
C++
dude?
libraries
Who
team.
are you?
I'm Robert Schumacher.
Oh, Robert Schumacher. That's your name. Okay, cool.
So I'm a developer on the C++ libraries team. I've worked on our open source projects in the past, and now I am primarily focused on working on the Vcpkg effort.
All right, so let's give everybody like a little introduction to the Vcpkg and what we're trying to accomplish. So like, what is this tool?
Right. So we've heard lots of developer comparisons between Windows and other platforms, and how the situation on Windows is a lot more difficult than some other platforms when developing native libraries, especially when using open source code. And what we've tried to do is we've tried to look at these other platforms, figure out what they're doing, and then do it as well as we can on Windows. So the Vcpkg is a package manager, which means that it's a program, it's a bunch of scripts, and it's a community that is designed to make these libraries easily accessible and productive for you as a developer.
Right. I mean, I think we've gotten a ton of feedback about like how hard it is to like move from one version of Visual Studio to the other. And in some ways, if we could create something where you could just go and get all of the third-party dependencies that you need in order to do things, it just like takes one more thing off of the list of reasons to wait for the old version.
Oh yeah, that's a huge blocker for a lot of people. Is, hey, I'm using Vcpkg and it's built with the older version of the compiler, so I can't upgrade, and that's really terrible, right? We've have lots of other Going Native videos about all of the improvements that we're always making in the compilers, and the fact that you guys aren't able to take advantage of that because of libraries is really terrible. So we're working on making that much better.
Okay, so Microsoft has things like NuGet, and then there are all these other apt-get, and when you use Ubuntu or whatever, like help them understand where we landed in this thing.
Right. So if you are a developer familiar with the way that Linux or Mac, in the case of Homebrew and Mac ports, do things, you will be right at home with Vcpkg. We have taken the essence of these platforms, of these solutions to this problem, and we brought them to Windows. If you are not familiar with those, don't worry. It is incredibly easy to use. So the idea is we have a set of scripts, and these scripts detail exactly how to build these libraries in various configurations on Windows. So when you go and you clone our Git repository, you get a bunch of scripts, you get the source code for our tool, and you get some build system integration glue as well. So what it does is you use the tool, you build it on your own machine, and you
when
run
you clone it, you get it from GitHub. This is way open source.
Right? Yeah. We're open source all of this. There's no reason why any of this should be open source.
Vcpkg, for those of you who are following along at home.
Yes. We'll have a link in the show notes. So you clone this Git repository. It has a bunch of scripts in it. And you have a tool. And this tool, when you run it, will figure out what you need. It'll figure out where it needs to come from. It'll pull it down to your machine, and it'll build those libraries according to the way that those libraries say they need to be built. So for example, in the case of OpenSSL, for anyone who's tried to build OpenSSL, you'll know that on Windows it's kind of like, wait, I have to download some particular version of Perl.
It builds just a little too much character.
Yeah, that's a fair way to put it. So when you invoke Vcpkg to install OpenSSL, we do all of that for you, and what you get out the other side is you get libs, you get DLLs, and you get headers. Done. Or if you're building statically, you only get libs, of course. And that's it. You get just a folder containing these files along with any other libraries that you've installed, and you can just use them. Now, for those of you who are, we really care about putting the include directive on the command line and putting the link line on the command line. You can totally use them like that if you have a custom build system. Totally works just the way you would expect. However, in Visual Studio, a lot of developers expect a little bit more productivity than that. So we have also added in some build system integrations. So what we've added is a way to make this system look incredibly similar to the situation you'll have on other platforms, where there is kind of a blessed directory that is always included in Linux platforms. This is /user/include. So if there are any header files in that directory, you can just include them. You don't need to explicitly add that include directory to your project. For developers on Windows who use the Visual Studio templates, this is kind of like how the Windows directory, windows.h, is just available. You don't have to explicitly add it to your command line. So we know how productive having these libraries available just by default can be. And so we've wanted to replicate that experience here. So after you install the libraries, you've got the libs, you've got the headers, you've got the DLLs. We automatically add the headers to your link or to your include line. We automatically link the libraries that you need, and then we automatically analyze your output and copy the DLLs that you used to your output folder. So what this means, all of those technical details aside, what this means is that from Visual Studio, you can go File, New Project, copy some sample code off the internet, paste it in, and build. And it'll run.
And it just works.
And it just works.
Right.
You don't need to faff about with what libraries like, oh God, I have linker errors. You don't have to faff about with any of that. It just works. It's just seamless experience.
And now when we started, I think you and Alex wrote most of the original kind of scripts, and I think we launched with maybe 21 or something.
Something like that, yeah.
Like, where are we at now?
We're at 94. The community response has been incredible. If any of our contributors are watching this, I want to say thank you so much. Your efforts are incredibly appreciated, and it's
if
incredible.
you're in Redmond, he'll buy you lunch.
Yeah,
but I'll
yeah.
expense it. So
Yeah, no, please. I would love to hear from you guys more than we already have, but it is an incredible outcropping. So thank you. It's an incredible outpouring.
And we're really tracking like the most common open source projects to make sure that they get available. And if we need to, we'll go do some more ourselves.
Yes, of course.
And such. Okay, so if you're we're really confident that if you're like a Linux person, you're going to feel pretty comfortable with the system that we built. Let's assume for a minute that you are a sort of Microsoft dyed in the wood kind of thing. We like you too still.
Yep.
And you're probably used to NuGet, right? Help those folks understand how those two things connect.
Right. So we've heard the experiences of a lot of people who have tried to use NuGet for C++, and the thing that we just keep hearing over and over is that it just is too hard. NuGet packaging up binaries into NuGet and then making them available and then keeping them up to date and dealing with dependencies between them is just an absolute nightmare. And this is really not.
Works great for C#.
Yeah, it works great for C#.
But
This is really not necessarily a problem with NuGet. I mean, NuGet is designed and it works great for C#. It works really well with languages where you have a reasonable expectation of being able to just change out the DLLs from underneath something and have them work.
Right.
In C++,
in binary distribution as opposed to source distribution.
Exactly. In C#, especially because of the nature of the C# language, some of the things that we do at compile time in C++ are actually done at runtime in C#, and that's one of the features that makes C# so much more amenable to this style of package management. You can also see like NPM, for example, is another good example of that kind of style. However, for native code, if you look around and you see who is successful at using native code, who really has a library solution that is clearly like the champion here. And what we find is apt-get, Homebrew, all of the other, I say apt-get, but all of the other Linux distributions, Pacman, Yum, Gentoo's, Emerge, all of those are fantastic. BSD's ports tree is clearly the ancestor to all of these. But on top of that, when you look at companies as well, when you look at Google, for example, they also do this. They have the source in their tree that they build alongside their projects. And that's really clearly the way that native code needs to work. That's really the best option for native code. And so we don't have that experience in NuGet, and so we felt like we needed to address that problem.
Okay, so we're hoping that over time that all of the major open source things, or anything that's sort of free and third party-ish that you can just grab, and that stuff will just be here and it'll be just magic. But I'm assuming that, and at least of the feedback that I've heard from customers on this initially as we've gone out, is a lot of people want to be able to use the same sort of thing for handling like their internal distribution things.
Yes.
What Can you give me a little bit about like how that should work, or how we've thought about that problem?
Right. So that is actually a really interesting issue. The way that we've kind of thought about it is we break it into two pieces. So if you are consuming internal built binaries from another organization in your division, do you want to treat these as though they came from, you found them on some GitHub website, on some GitHub repository somewhere, on some Bitbucket repository somewhere? If you want to treat them like a totally third-party entity, then Vcpkg will work great. You can package them up inside of Vcpkg. You can build them from source using whatever build system they use. We don't put any restraints on that. And we will automatically rebuild them if any of their dependencies get updated. And so in this way, you can easily say, hey, we're ready to update to Boost, but our other org hasn't given us a new drop. Well, not a problem. If we package it in Vcpkg, it'll build from source every time, so there's no issues, and it'll track and make sure that whatever version of Boost we end up using, it's going to be built against that version of Boost, so there's no issues there.
Right. It's just this whole, I think that's one thing that maybe we haven't stressed quite enough yet, which is this idea of it's a consistent set of libraries.
Yes.
It's not just a set of libraries.
Yes. That's a huge issue in native code, is the consistency between the libraries, and so Vcpkg, like other package managers, is designed to enforce this consistency in the very nature of its operation. So this means that you are guaranteed to only get a single version of a library during your build. This is a huge issue. We've seen it across many, many companies. We have some issues internally along those lines. And
anything at scale.
Anything at scale hits these issues. And so the real solution to this problem is to design it out from the beginning. And that's what we've done with Vcpkg.
Okay, great. So we're going to do a demo in a minute here, but I just want to make sure that people understand, like, how do you get this, and which versions of Visual Studio does it support?
Right. So you get it from GitHub. All of it's on there. It's completely open source.
Super self-documenting.
Super self-documenting. Yes, we've done a lot of work on the user experience. If you hit a snag, send us a mail or make an issue on GitHub, and we would love to hear from you. We want to make the user experience fantastic, as you've come to expect. So as far as Visual Studio versions, we currently support Visual Studio 2015 and 2017. However, you will need Visual Studio 2015 installed. A lot of libraries currently build against Visual Studio 2015 and are not really easily retargetable to 2017, but they're both binary compatible with each other.
I was going to say that this is probably a great time for us to re-emphasize this, because it's actually never happened before, and so I suspect that we're in a place where people are like, wait, what?
Yes.
Visual Studio 2017 and Visual Studio 2015 are binary compatible releases.
Yes.
Yes, there are source breaking changes that exist between them. We've worked really hard to keep them small. But you can indeed take a lib that was built in Visual Studio 2015 and link it up against another lib that was in Visual Studio 2017. So we're hoping that you kind of take Vcpkg, you Vcpkgize yourself, and now you're kind of good to go going forwards, right?
Yes.
You get that 2015 thing, and now you swap in 2017, and bam. No need to wait 3 years for all the libraries to catch up to migrate. We want you guys to take advantage of all that stuff I did in the first half of the episode, right? The productivity increases and the perf stuff.
Yeah. Those things are really useful, and you can continue reaping the benefits of all of them. So you will need Visual Studio 2015 installed, but once you have that, you only need that to build the libraries. You can just completely forget it's installed on your box and use 2017 for everything else.
Great. All right, let's take a look at the demo.
So to get started with Vcpkg, you will first want to go to our GitHub page, which is simply github.com/Microsoft/Vcpkg. And on the GitHub page, you will find the clone or download link. Definitely you need to clone this. We rely on Git for some of our operations, so downloading the zip file, and you may encounter some issues. So after copying the URL, you can go to your command prompt and do your normal git clone operation, so git clone and that URL. Now, you can clone through Visual Studio as well, and that will work fine. However, you will need Git installed on your machine and accessible from the command line, so I recommend using the Git for Windows distribution for that. So now that it's cloned, we can go into the directory and we can run the bootstrap command. So the bootstrap command is listed in our README. And you can see here whether you are in command or in PowerShell, this script will correctly invoke, and it will build the Vcpkg tool on your machine. The sources for the tool are available in the repo that you just downloaded, and you're free to browse them, you're free to edit them, and submit pull requests against them if you can find some way to improve them. Okay, so now that the tool is built, it's been dropped directly into the root folder, so you can see here we have vcpkg.exe, and when I run that, it lists the output. Now, on your machine, hopefully you have a higher resolution monitor and you'll be able to see this in a much nicer format. But this gives you a good overview of the top-level commands that you can execute. So the first command we're going to run is search. Search will give you a list of all of the packages that are available. And as you can see, we have quite a few. So for this demo, we're going to use zlib, which is a very common library. And as you can see, when we run vcpkg search zlib, we've narrowed down the results to just the zlib library. We can then install this library very easily by running vcpkg install zlib. And what this is going to do is it's going to download the source code from zlib off of the zlib website. It's going to check it using a hash to make sure that it is the exact same version that you are supposed to get. And then it is going to extract it, and it's going to build it using a preset script that we have in the system. We call these scripts port files, but they're very analogous to Homebrew's Formula or other packaging systems. Okay, so now that that's installed, we can move on to using it in Visual Studio. So the first step to use it in Visual Studio is to run integrate install. And what this is going to do is it installs a file into your local directory as well as a file into your MS Build installation, which connects this particular copy of Vcpkg, the one where we just built zlib, into your Visual Studio and your MS Build installation. What this means is now you can use the zlib that you just installed just like that, nothing else required. So we're going to switch over to Visual Studio where I have an empty project. So this project in Visual Studio is exactly the same project you'd get using File, New Project, Empty Project, except that I've added a single source file, source.cpp. Now, we wanted to use zlib, so if I simply do include zlib, you'll see that autocomplete has already picked up the zlib that we installed inside of Vcpkg, and it's made autocomplete available. And then I can simply write int main, and I can print the zlib version. And you can see that we are getting autocomplete on the version, the zlib version function available inside of zlib.h. This function simply returns a string which contains the literal version of the zlib DLL that's being loaded. So this looks pretty good. I'm going to build it, and I'll drop a breakpoint on the return statement, and then we'll run it once it finishes building. And as we can see, it did execute correctly. We got the version of the zlib DLL. We didn't need to worry about the include path. We didn't need to worry about the link line. Everything just worked. Now, this project actually got the zlib DLL, and that DLL was automatically copied to the output folder by analyzing what you actually used in the project. So we used zlib this time, so we got the zlib DLL. However, if we had more libraries installed, those libraries would not be copied into the output folder unless they are actually used by your project. Now, in Visual Studio 2017, we've added CMake support into the IDE itself. We know how popular CMake is, so you can definitely use Vcpkg directly from CMake as well. So if I go into my folder here where I have a CMake project, you can see I have a CMake list.txt, and this CMake list.txt is a simple project that uses zlib, and it uses that same source file we have in Visual Studio. So we simply need to configure our CMake in the normal way while also specifying a toolchain file from the particular Vcpkg instance that we would like to pick up packages from. The particular subdirectory is scripts build systems vcpkg.cmake. So in any copy of Vcpkg that you have on your machine, you're able to select that set of packages. So as you can see, it picked up zlib and the project's ready to build. So we can simply run CMake build dot, and we can see that it built successfully. And in our output, we have a main.exe, and we can run that, and we get the exact same result we got inside of Visual Studio.
Okay, so hopefully you found that demo very compelling and easy to use. You mentioned at the beginning that Vcpkg is really a set of tools, a set of scripts, and a community. So if people want to get involved in that community, what should they do?
Right, so we have already a bunch of contributors on GitHub. It's incredible. You just go to GitHub, file an issue. First, download Vcpkg, use it, then come back to GitHub and let us know. Let us know, does it work for you? Does it not work for you? So you can send us direct email if you
What are you
prefer for that.
missing?
Yeah, what are you missing? And we are, honestly, most of the libraries that we have today were contributed by external contributors. So please, if you have a library that you don't see and you say, you know what, this tool is awesome, I want to have that library, package it, submit it, we will accept it.
Yeah, my favorite was when we were at CMake a couple of weeks ago, and people would come up and say, oh wow, I wish you had such and something, and like Robert would literally like make them sit at the keyboard and then like submit them, and then he'd go and commit them, and so like it's really actually easy. Like I've watched a bunch of people just do it, and it should be an easy start for you folks.
Yes.
And if not, you can bother Robert.
Yes,
Not
please.
me. No, Robert.
Please.
Yeah.
If you have any experience, if you go to package a library and you are unsuccessful, tell us. We want to make that experience as easy as possible.
Yeah. This is intended for every library.
Yes.
Okay, so that's Vcpkg. Also, please, by all means, download the Visual Studio 2017 RC build. We're going to be right on the other end of that developer community website. If you're hitting any issues at all, we will jump on them. I'm expecting you to see great performance. If you're not seeing great performance, tell me. I still have time to fix things. So come and really pound on those bits. I'd really appreciate it. All right, thanks, and we'll see you next month.
Thanks.